So I told you, so first, welcome back. I told you that we alternate between theory and practice. Some people like theory better, some people like practice better. So I'm alternating a little bit in the structure of the course. And since we spent a bit last week and today in theory with scary mathematical formulas, now is a bit of a more practical lecture of how do we do that math, but in practice implemented in SQL. So we saw, just a quick recap. We saw that the name relational table, relational databases now comes from mathematical relations. Now you know why. So this is why we sometimes call them relations. I really need to be close to the laptop because otherwise it's not advancing. Okay. So you saw a relation, if you define it on two sets, that's just a subset of the Cartesian product. Or put informally, it's just a bunch of lines that connect these to this. So that's a relation. We saw that a map is a special kind of relation, except that you can at most have one. You cannot have two or more associations for each item on the left. So it's 0 or 1, either you associate or you don't. And a function is exactly one. Every element on the left must be exactly associated with one element on the right. You notice, by the way, here I have these little arrows here, because there is really an asymmetry. There is really a direction here, the same for the maps. But you see that here I don't have any arrows. That's because the relation is completely symmetric. Right? You can swap the sides and you still have a relation. That's the reason. Okay. We saw, I'm repeating, but that way I'm sure you'll remember, it's called space repetition. That's a Duolingo technique. Who uses Duolingo? Right, it's a little bit the same idea. I'm just repeating things regularly and then you remember for the very long term. So we saw a collection is, with my chocolate taste, it's a set of records, maps. And because that would also be a collection, I need to enforce three additional criteria to make it a relational table. These ones, then we call it a relational table, chocolate flavor. Then we have the vanilla flavor of relations with bags. So I say it's a bag of maps. A relational table is, oh, I forgot table in there. Relational table is a bag of maps plus this that fulfills these three. And then I have the strawberry flavor with the list of maps that also fulfills relational integrity, domain integrity, atomic integrity. Okay. Now, SQL. Who heard of SQL before? Who never heard of SQL? Okay, well, I have good news for you because SQL means structured English query language, and at least the original name. So it's meant to be intuitive and sound a bit like English. I'm not saying it's an LLM, that's not ChatGPT, but it does a little bit feel like English. So what you see on your screen, by the way, is a SQL query. So I'm going to give you a little bit of a history of how things happened. So the early days, so one of the people involved was Don Chamberlain and another Raymond Boyce. Boyce gave his name to the Boyce, the Boyce code normal form that we'll see in a couple of weeks in the theory. So I'm just saying this is the a person who gave his name to it. And so they came up with the structured English query language. So historically, first you had in 1970 this seeding paper by Edgar Cott on that introduced the notion of data independence and the relational model and so on. And then came the implementation. The implementation was done at an IBM facility in San Jose. Who was ever in California? San Jose, it's a city, so you have the Bay Area, so you have San Francisco, and then the whole Bay Area along the 101 that goes through all the way through the Stanford campus, all the way to San Jose, and San Jose would be at the south end of that. You need to cross a bit of desert, but not too much. And then you have this laboratory. It still exists today. And then if you continue, you have hours of road, even more, and then you are in Los Angeles. So the first system that was invented, commercially available, was called System R. R, guess what, for relational. And the language, SQL, written like this, structured English query language. So that was the language that manipulates table, right, in a data-independent way, plus the first customer, and you see that was 7 years later between the paper and the actual first customer, 1977, Pratt & Whitney. I think they still exist today, if I'm correct. All right. So the goal of that structured English query language, first, is that it should be easier than C or Fortran or COBOL or all of these languages you had at the time. It was supposed to be easy to use, and it is actually easy to use. And it is declarative. Declarative means that you just state what you want. Let me come back to this example, just to say what I mean with declarative. Here, this one. I declare herewith that I would like a table where I take my data for a relational table from a relational table called cities, but I do two things. The first thing is that I only want to have these cities where the country is Switzerland. Do you remember predicate? I told you about the predicates to select some tuples. That's a predicate. Country equals Switzerland. That's a selection. So I declare that I only want the cities whose country is Switzerland. And I declare that I'm only interested in the name and the mayor. That's the columns I want. It's declarative. I state that this is what I want. How is that going to be done? On disk, reading on disk, and via the CPU and so on? I just couldn't care less. I'm the user of the system. I'm just saying what I want, and then the engine does its thing. That is data independence. PostgreSQL was the work like any other database engine, IBM, Oracle, Microsoft SQL Server. It's been implemented by thousands of engineers who took care of everything for you in such a way that you can just say this, just these 3 lines, this is what I want, and then it's going to happen. That means declarative, right? So this is what I mean, right here. It's like the difference between cooking or just going to the Mensa and asking for a menu, right? Declarative, you ask for the menu and the details of the cooking are basically delegated to other people who are excellent cooks, by the way. Everybody is with me on declarative? All right. The beauty of declarative is not just that you don't need to worry about the details, and many people wouldn't know about the details. It's also that the implementation of that only needed to be done once by the engineers. They implemented it once, and then it's reused all over the place for the whole world, that same implementation by everybody, by experts who know what they are doing. They came up with good algorithms and very efficient implementations so that it's just fast for everybody. And if you update your system 1 year later, maybe it's going to be even faster. That's data independence. They keep improving it, but SQL doesn't change. Still the same program. You don't need to modify anything. It just becomes faster at every update. All right, so that's the declarative part. What does set-based mean? Well, sets of maps. That's what it means. What it means is that if you have a language like Java, C++, Python, who already use the language like that? Most of you, I guess, right? In those languages, the imperative languages, usually what happens is that when you have a variable in this language, that variable is associated with one thing. It can be one integer, it can be one string, it can be one dict, it can be one object. In Java, one thing at a time. But in languages like SQL, we don't handle one thing at a time. We handle millions, billions, trillions of things at a time, trillions of records, right? So you write basically something like this, and you are handling billions or trillions of records doing that. So this is why we say it's a set-based language, right? Okay. And then SQL, you notice the different spelling. That was because of a trademark issue, because some people sued and say, no, SQL is already used, you can't use that. So they say, okay, fine, we'll just rename it as SQL. And this is the reason why today you have people who say SQL, you have people who say SQL, but it's just the same thing, right? It doesn't matter. Okay. I think I should let you go. 7 minutes, and we are ahead of time. Again, you're a great class. Who is hungry? Who wants to go to the Mensa? Okay, so I'm going to free you, and there's the exercise sessions, of course, this afternoon and on Monday. And then next week, I'll continue with this, and I'll drive you through the practical aspect of SQLs and defining schemas and tables and types. And of course, you will be able to do it yourself in Jupyter notebooks. So thank you very much. Thank you, Martin, for the moderation. Thank you for your participation. And I'll see you next week at 10 a.m. Thank you very much.